I always thought that sea crossing bridges were built directly from the seafloor. Until I really watched the construction of the sea crossing bridge, I found that the process is not simple. Let's take the most typical suspension bridge as an example. A suspension bridge mainly consists of bridge towers, anchorage systems, main cables, suspenders, and deck. But what many people don't know is that the most important part of a suspension bridge is never the deck, but the two seemingly inconspicuous steel cables. When a car drives on the bridge, the weight will not be directly pressed on the tower. It will be lifted by the cables one by one, and then all handed over to the main cable above. When the main cable is stressed, it will be stretched like a bowstring to the limit. It will be stretched tightly and distribute the force to both sides. At this time, the function of the bridge tower is actually to hold the main cable in the air, preventing it from collapsing. The real ones that bear the huge tension is the anchor system buried deep in the ground at both ends. How is this giant bridge built? The first step in building a bridge is never the bridge tower you see, but the underwater pier foundation. To build foundations in deep water, the common methods are pile foundation, cofferdam, and caissons. Let's first look at the simplest pile foundation method. During construction, first, a hollow steel pipe is driven into the seabed. Dig out the sediment inside, then insert the steel reinforcement cage, and finally fill it with concrete. Pile is completed like this. Hit more piles, and connect their tops with concrete. A solid pier is formed. This method is suitable for shallow water and stable geology. What if it's in deep water? You must have thought of to enclose a dry area in the sea first. Engineers' approach is first use steel sheet piles to enclose a large circle in the sea. These steel plates are not just inserted randomly, but to be deeply driven into the seabed. The purpose is to prevent the sea water from entering. When the piles are connected end to end, a temporary steel wall appears. This method is called cofferdam method. It's proved to be good. The next step is to pump out the water. In theory, as long as the water inside is pumped out, we can start construction on the seabed. But there are gaps between the steel plates. Water will keep seeping in, which can't be pumped out. Engineers simply built another layer of cofferdam inside. The outer circle blocks the seawater, and the inner one to stop seepage. The middle layer is filled with concrete directly. When the concrete solidifies, all the gaps will be completely sealed. But when the water in the cofferdam is pumped out, the huge water pressure will try to squeeze the cofferdam in. Without support, the cofferdam will collapse inward in an instant. So before pumping water, engineers must first install multiple layers of steel support frames, just like supporting the wall frame, to withstand the external water pressure. Even so, water will still seep up from the ground. As long as the bottom is not sealed, the water in the cofferdam can never be pumped out. So the smart you pour a whole layer of concrete directly at the bottom, completely isolating the groundwater. At this point, you finally get a truly dry and safe construction area. Then workers use steel bars to build the skeleton of the pier, then seal the formwork outside, and finally pour the concrete at one time. When the concrete is fully solidified, a real underwater pier is born. Then the cofferdams above the sea will be removed. Otherwise, it will be an obstruction and affect the landscape. However, the cofferdam method has its limits. Generally speaking, the water depth exceeds 12 meters. Costs and risks will rise sharply. What if the water is deeper? You can simply change your mind. Don't build piers in the sea, but prefabricate the entire pier on land in advance, and make it a hollow structure inside. First, it reduces the weight, and for convenient transportation. When all is done, then use a tugboat to the designated location, and sink it slowly, and sink precisely onto the seabed. Finally, fill the hollow part with concrete. A super large underwater foundation is completed. This method is called the caisson method. When the underwater foundation is completed, the construction of the bridge tower officially begins. At this time, the construction area is no longer underwater. The process is similar to that on land. After the tower is built, the main cable needs to be erected. It determines the success or failure of the suspension bridge. From a distance, the main cable is as thin as a thread, but when you get close you will find its diameter can be thicker than a person. It's not a whole steel rope, but is composed of thousands of thin steel wires. During construction, workers will first pull a temporary cableway to allow the transporter to shuttle back and forth. The steel wires are sent one by one, and then pull them back. This process is repeated thousands of times, until all the steel wires are tightened and bundled. forming a bamboo cable that can really carry tens of thousands tons. This process is called cable spinning. It often takes several months to make a bamboo cable. The anchor at the top of the tower is where the cable is finally placed. After all the cables and slings are installed, the bridge deck can be assembled. But the deck cannot be installed casually. It must start from the bridge tower position and extend symmetrically to both sides section by section to ensure the balance of force. This is the whole process of a giant suspension bridge. The whole process of growing out of the sea. Now do you understand?